Hello viewers on YouTube. In this video tutorial, we are going to consider going through some practice problems involving the derivative of logarithmic functions. When we talk about logarithmic functions, we are talking about functions that involves log. It might be natural log or a common log. That is a log to some other base, maybe 10 or so. So let's talk about what you need to know first. If y is equal to a function of x, such that the function involves a log, for instance, let's say natural log remain x, then the y dx, which is the derivative of y with respect to x, is simply equals to 1 by x. So in other words, you can see it as the derivative of x divided by x. X prime is simply 1, and that gives us 1 by x. So some textbooks might express the formula as this. However, if you are curious about how the result is gotten, feel free to check out the proof video in the link in the description. I leave the link to that. So that's basically the derivative of y with respect to x if y is equal to ln x. Likewise, if y is equal to log of some other base a to x, then the derivative of y with respect to x is simply equal to, yes, 1 by x, but with the product of ln a. Now this can, in other word or in other way, be expressed as 1 by x log of base a to e. So it depends on how you see the answers, if you're dealing with multiple choice questions, or it depends on how you want your answer to be if you're dealing with theory questions. So basically, we flip this one by using our knowledge in properties of log. We call that techniques or concepts, we call it the change of base. So we change the base because this is ln a, which is the same thing as log of base a to e. Then we change the base to log of base a to e. It is initially log of base e to e. So in the process of doing that, there will be a reciprocal. That's not for this video, okay? However, I also have video on that. I will leave the link also in the description. So these are the two things you have to keep in mind while dealing with problems involving the derivative of logs. Now, one more thing I need to make mention of, which is very, very crucial and very, very important. When you're dealing with problems involving the derivative of logarithmic functions, please and please, what you want to do is that, regardless of how compound or complex the argument is, this is what we call arguments, try to make it simple. In what manner? You want to set the entire argument to be equal to a monomial, typically a linear. When we said linear, yes, sometimes some linear might not be monomial, some linear might be binomial, but you want to make it to be linear and monomial. What am I saying makes sense? You want to make it to be like this. This is a linear expression or function, and it's a linear and it's a monomial. Am I communicating? So what am I saying makes sense? Consider y to be equal to ln x plus 2. Yes, this is linear, but it's binomial. So basically, you want to take this entire stuff and set to be some other new variable u. So this can become y to be equal to ln u. Now you can now use your chain rule, do this one, and multiply them together. This will make life easy for you. Am I communicating? Perfect. Now let's put this into good use. Example number 1. Consider y to be equal to log of base a to 3x plus 2. So feel free to pause the video and figure this out yourself if you know what to do. So basically, we will take this entire expression and set to be equal to some other new variable u. Thus, y will become log of base a to u. Now it's easy for us to differentiate this. Likewise this one. So what would be the y, the u? Well, that would simply be 1 over u ln a, or in other words, 1 divided by u log of base A to E. But we don't want to keep using this. Let's make this straightforward. However, the choice is yours. So 1 over u then A. Likewise, what will be the u dx? The u dx will simply be equal to 3. Hence, our final answer, the y dx, would simply be equal to the product of the y du and the u dx. And so therefore, we got our final answer to be 1 over u ln A multiplied by 3. When we introduce u, question is in term of x, so answer must also be in term of x. Upon replacing u and simplifying to the base form, we got our final answer to be 3 ln A divided by 3x plus 2. That's the result to example number 1. On to example number 2. Consider the function y that is equal to ln 1/3 of x cubed, let me write that properly, minus 2x squared plus 5x minus 1. So feel free to figure this out yourself. After that, you can pause it and see if you have done the right thing. So just like before, let this entire polynomial be equal to a new variable u, just to make things simple. So we have 1/3 of x cubed and minus 2x squared plus 5x, this is squared, minus 1. Thus, our y is now ln u. It's easy for us to differentiate u. Likewise y. So the y du is simply, this is ln u. Make sure you know the difference compared to the previous one. The previous one was log of base log of base A to u. So the result of this one will simply be 1 over u. We don't need to multiply with any log of or ln at all, because it's just as if you're having log of base E to E or ln E, and ln E is simply 1, which actually cancels out. Am I communicating? Perfect. So now, what about the u dx? It implies the u dx will simply be, differentiating this entire polynomial would simply be x squared minus 4x plus 5. I hope this part is clear. You should know how to differentiate polynomial. This is the part of the division line. Okay, so the 3 comes, it multiply this one, gets rid of it entirely, and it reduces to 2, and that's why we have x squared left here. The 2 comes, multiply this one, and hence we have 4, and it reduces by 1, and that's why we have 4x. Now this 5x is simply 5, so that's how we got our final answer. So now, getting out the y dx will be the product of the y du and the u dx, and so therefore we got 1 over u times x squared minus 4x plus 5. So if we replace back, we have x squared minus 4x plus 5 to be divided by 1/3 of x cubed minus 2x squared plus 5x minus 1. So that's our result to example number 2. By now I want to believe you should have been getting used to the tactics of solving problems involving logarithmic functions. Let's try one more example. Consider y that is equal to ln 4x minus 1 all squared. Now, you can actually solve this problem in 2 different manners. Well, that will depend on how solid your understanding is in properties of log. Let me show you something. If we said u is equal to 4x minus 1 all squared, it implies that y becomes ln u. Now this is easy for us, as we now have it in the way we have been expressing the previous examples. But you know that doing it this way, you will end up having the same answer as doing it this way. So what way? Instead of setting u to be equal to 4x minus 1 all squared, can we set u to be equal to 4x minus 1 alone? If we set that, then it means y will be equal to the lane u all squared. So how do we do this? But I said earlier, make sure this is linear and monomial. Yes, this is non-linear, but we can still make it linear by what? By taking the 2 to the front of the log from our knowledge in log. So that it can now become linear, and then we started applying our formula from there. So the choice is yours, but we want to make things straightforward. We don't want to change our roots. We want to keep on taking the same pattern. However, keep in mind that doing things different using different pattern is highly recommended, so you can be getting different results and what you can be comparing the results. Perfect. So now let's simplify forward. So what will be the y du? That will be 1 over u. Likewise, the u dx. We are using chain rule here, so 2 come first. So we have 2 times derivative of 4x minus 1 is simply 4, and multiply by 4x minus 1. Reduce this by 1, that's just 1. So that's simply 8 4x minus 1. Well, if you want, you can expand, but I don't want to expand. So my final answer, the y dx, will be equal to the y du multiplied by the u dx, and hence I got 1 over u times 8 4x minus 1, which is simply 8 4x minus 1 divided by 4x minus 1 all squared. So where did I get that? The value of u. Remember, now this is a algebraic fraction. This can reduce this. Our finest answer is 8 divided by 4x minus 1. And that gives us the result. So example number 3. And guys, this is how you can easily differentiate logarithmic functions. I hope you find this helpful and understandable. Thanks for watching. This is the exercise I have for you. So consider y to be equal to the limit 1 minus x squared divided by 1 plus x squared. Feel free to share your solution with me via the comment section below. And for those who might be wondering or who might be curious that I don't give you an example like this, or am I giving you as an exercise? Well, it's just the structure that looks completely different. We are saying applying the same process and logic. So give it a try. Bye for now.